Welcome. This video is a product of Aviation Training Foundation. It is designed to help students understand the procedures used in troubleshooting DC electric circuits. Prior to viewing this video, students should have a basic knowledge of how electricity works, and knowledge of the procedures required to measure volts, ohms and amps. This lesson is designed to teach aircraft mechanics methods for troubleshooting aircraft circuits, but the procedures can be applied to any electrical circuit. For an electrical circuit to function, the circuit must have a source of EMF or electrical power. In this case, a battery. It also must have a form of resistance such as a light bulb or a resistor and a conductor which allows the flow of electrons from the source through the resistance and then back to the source. Any circuit used on aircraft must also have a control device such as a switch and a protection device such as a fuse or circuit breaker. All of these physical components are represented by symbols on the schematic diagram. The schematic diagram is used to understand how the circuit is wired, but does not actually show the physical location of the components. To help you find the actual physical location, a wiring diagram is used. It will identify the wires and the terminal connections and connector pins using numbers or letters so that a reading can be taken with a meter. The technician should study the schematic and the wiring diagram before beginning to troubleshoot. The first step in troubleshooting is always to understand how the circuit works normally without any faults. If you don't know how it is supposed to work, how do you know if something is wrong with it? Here is a basic circuit. When the switch is turned on, electrons flow from the negative battery terminal through the bulb and back to the positive terminal. The chemical reaction in the battery removes the electrons from the positive terminal and moves them to the negative terminal, and the process repeats until either the switch is turned off or the chemical reaction is used up. The battery process is explained in another lesson. If the battery was not connected to the wires in the circuit, the electrons will accumulate on the negative terminal as they are removed from the positive terminal. Because there are more electrons on one terminal than the other, we say it is charged. When there are more electrons in one location when compared to another location, we call that the difference in potential. When troubleshooting an electric circuit, we are using a voltmeter to find the difference in potential. Before we actually start troubleshooting, we need to understand what can go wrong with a circuit and what are the normal measurements. Things like the circuit not operating, or a light not working, or a light getting dim or brighter are not faults, they are symptoms. Symptoms are identified to help you determine what to test to find the fault. There are only 3 faults that can go wrong in an electrical circuit. They are an open, a short, or a change in resistance, which in most cases goes up. An open is a break in a conductive path. This causes the resistance in the circuit to reach infinity. A difference in potential will form at the open. A short occurs when the resistance is bypassed. In a short, resistance is equal to 0 through the short. A device can be shorted, including resistors, light bulbs, switches, and breakers. A switch is actually used to create an open in the circuit when it is in the off position and creates a short when it is in the on position. If the switch becomes actually shorted, you will not be able to shut it off. If a breaker becomes shorted, it will not function properly but will appear to work normally unless it is shut off. Then the circuit will continue to operate. If a short occurs in the resistance or load, it may cause an increase in current, and the fuse will melt, or the circuit breaker will pop open. This is the purpose of the protection device. It changes a short to an open to prevent the circuit from catching fire or melting from too much current. When this happens, it is referred to as a short to ground. In most cases, a short can be identified without using a meter just by observing the symptoms. When high resistance occurs, resistance is found somewhere in the circuit that is not normally there. Lights will go dim, or even go out, but a small current will still flow in the circuit. A voltage drop will form at the point of high resistance. The voltage drop on the normal load will be less than the source voltage. The total voltage will be the sum of the voltage on the load and the high resistance voltage drop. Next, if we are looking for an open in a circuit, we cannot test it with an ammeter because this meter measures current flow. If an open occurs, there is no current flowing. In addition, ammeters must be connected in series, which requires cutting the wire or removing parts to insert the meter. Finally, if an open occurs in a circuit, we know the difference in potential or positive and negative charge forms at the open. This can be tested by using a voltmeter. The voltmeter will only indicate a voltage when it is placed in parallel with the open. There is a simple method used to track down the open, but before you can do this, you must understand what the normal readings should be. Okay, let's go back and look at our normal simple circuit to see what kind of measurement we can find. What type of meter should we use? We cannot use an ohm meter to test an active circuit. The ohm meter has a battery built in as its power source, and the components in the circuit must be isolated from the circuit when testing. We don't want to remove solder from components or cut wires to use the ohm meter. It will only be used to test the continuity of the wiring harness at the connectors or terminal blocks. Let's start at the battery. The battery has two battery posts. When we reference a positive or negative in a circuit, it is not a physical location, it is a reference to direction. The same location in the circuit can be referred to as both positive or negative depending on the other reference point. However, the battery posts do not change. The positive post is always positive and the negative post is always negative. The chemical reaction inside the battery moves electrons from one battery post and places them on the other battery post. If the battery is not connected to a circuit, the electrons cannot flow back to the other post where they came from. Therefore, one post has more electrons than the other. This forms the difference in potential. The post with less electrons is the positive post, and the post with more electrons is the negative post. Placing a voltmeter across the battery post will indicate the voltage or difference in potential. Next, we will physically connect a battery terminal to each of the battery posts. The electrons on the positive battery terminal are drawn off the terminal and placed on the battery terminal on the negative side. So now, both the terminals as well as the post become charged. The difference in potential can be found on both the post and also on the terminals. They will register on the voltmeter by touching any place on the terminals or post. If we then connect a wire to the battery terminals, the electrons on the positive battery terminal are drawn off the wire through the terminal and battery post and end up on the negative side of the battery. As long as there is a path for the electrons to flow, they will be pulled off the positive side and accumulate on the negative side of the battery. Let's take a look at a full circuit using schematic symbols. If the circuit breaker is in and the switch is turned off, there is a complete path for electrons to flow all the way from the switch to the positive side of the battery terminal. This is what happens in a normal circuit. Electrons will be pulled from the one side of the switch to the positive side of the battery and then through the chemical reaction in the battery, deposited on the other side of the negative battery terminal. Electrons on the negative side of the battery terminal will then be pushed along the circuit until they reach a break in the circuit path. So, in a normal circuit, with the switch off, or in the open position, the difference in potential exists at the switch terminals. Placing a meter across the switch will read the source voltage. There is no current flow. So, in a normal circuit, with the switch off, or in the open position, the difference in potential exists at the switch terminals. Placing a meter across the switch will read the source voltage. There is no current flow. When the switch is closed, current will flow in the circuit. In a lighted circuit, the light bulbs will illuminate. And, at that instant, the difference in potential will move from the switch to the load. One side of the total load will be positive, and the other side negative. If there are several lights in series, each light will have its own voltage drop and their sum will be the total voltage. The total voltage will be equal to the source. If the switch is opened and the breaker remains off, the electrons are pulled from one side of the breaker and are placed on the negative side of the circuit up to the switch. They cannot cross over the switch. The wire between the switch and the breaker is neither positively charged nor negatively charged. In this case, it is neutral. The voltmeter only reads the difference in potential, so there will be no reading when both meter terminals are negative or when both meter terminals are positive or when any one of the terminals are neutral. Never assume a meter terminal is positive if it is not negative. It might be neutral and the same is true if it is not negative. Always verify the potential with an actual meter reading. If an open occurs in the circuit, the positive and negative potential will move to the open when the circuit is turned on. To troubleshoot an electric circuit with an open, you simply need to locate the positive and negative potentials. Wires are connected to terminal blocks, which allows the connection of the meter without removing insulation from the wire. Terminal blocks and terminals are identified by numbers on wiring diagrams. A reading is taken using a voltmeter by connecting one side of the meter to a known positive or known negative. For example, if I connect the red lead to the positive battery terminal and leave it there, then every time I touch a terminal with the black lead and get a reading, the terminal can be identified as negative. If I get no reading, I cannot assume it is positive. I must switch the leads around and connect the black lead to a known negative. Now when I touch any terminal and get a reading, I can identify it as positive. Every time I touch a terminal and get a reading, I can identify it as positive or negative. However, just because I can identify the potential of the terminal, that doesn't mean it is in the circuit I am troubleshooting. Most schematics, or wiring diagrams, contain multiple circuits mixed together. I may need to trace the circuit path to make sure I am following a complete path. I should start from the negative battery terminal and trace it back to the positive battery terminal while passing through the proper load and switch device. It is similar to highways on a road map. I don't need to know where every highway goes. I only need to follow the one that gets me where I want to go and then back to where I came from. In summary, in a normal circuit, when the circuit breaker is in and the switch is open, the difference in potential exists at the switch. When the switch is closed, the difference in potential moves from the switch to the load. If the circuit breaker is pulled, the difference in potential moves from the load to the circuit breaker. If the circuit breaker is in and the switch is closed, but an open occurs, the difference in potential moves to the open. The open is found by identifying the positive and negative potentials when testing terminals. The point where they meet is the location of the open. In Part 2 we will use training boards built by Aviation Training Foundation to troubleshoot actual circuits. This video was made in association with Epic Flight Academy's Aircraft Mechanic Program. For more information on Epic's program, contact Epic Flight Academy.